Problem solving. Proportions and rates. If you wanted to power the city of Seattle using wind power, how many windmills would you need to install? Questions like these can be answered using rates and proportions. Rates. A rate is the ratio, fraction of two quantities. A unit rate is a rate with a denominator of 1. Example 12. Your car can drive 300 miles on a tank of 15 gallons. Express this as a rate. Expressed as a rate, 300 miles divided by 15 gallons, we can divide to find a unit rate, 20 miles divided by 1 gallon, which we could also write as 20 miles divided by a gallon, or just 20 miles per gallon. Proportion equation. A proportion equation is an equation showing the equivalence of two rates or ratios. Example 13. Solve the proportion 5/3 equals x over 6 for the unknown value x. This proportion is asking us to find a fraction with denominator 6 that is equivalent to the fraction 5/3. We can solve this by multiplying both sides of the equation by 6, giving x equals 5/3 multiplied by 6 equals 10. Example 14. A map scale indicates that 1/2 inch on the map corresponds with 3 real miles. How many miles apart are two cities that are 2 1/4 inches apart on the map? We can set up a proportion by setting equal to map inches divided by real miles, rates, and introducing a variable x to represent the unknown quantity. The mile distance between the cities, 1/2 map inch divided by 3 miles, equals 2 1/4 map inches divided by x miles. Multiply both sides by x and rewriting the mixed number. 1/2 divided by 3 multiplied by x equals 9/4. Multiply both sides by 3. 1/2 x equals 27/4. Multiply both sides by 2 or divide by 1/2. X equals 27 divided by 2 equals 13/2 miles. Many proportion problems can also be solved using dimensional analysis, the process of multiplying a quantity by rates to change the units. Example 15. Your car can drive 300 miles on a tank of 15 gallons. How far can it drive on 40 gallons? We could certainly answer this question by using a proportion. 300 miles divided by 15 gallons equals x miles divided by 40 gallons. However, we earlier found that 300 miles on 15 gallons gives a rate of 20 miles per gallon if we multiply the given 40-gallon quantity by this rate. The gallons unit cancels and we're left with the number of miles. 40 gallons multiplied by 20 miles divided by gallon equals 40 gallons divided by 1 multiplied by 20 miles divided by gallon equals 800 miles. Notice, if instead we were asked how many gallons are needed to drive 50 miles, we could answer this question by inverting the 20 mile per gallon rate so that the miles unit cancels and we're left with gallons. 50 miles multiplied by 1 gallon divided by 20 miles equals 50 miles divided by 1 multiplied by 1 gallon divided by 20 miles equals 50 gallons divided by 20 equals 2.5 gallons. Dimensional analysis can also be used to do unit conversions. Here are some unit conversions for reference. Unit conversions. Length, 1 foot equals 12 inches. 1 yard equals 3 feet. 1 mile equals 5,280 feet. 1,000 millimeters equals 1 meter. 100 centimeters equals 1 meter. 1,000 meters equals 1 kilometer. 2.54 centimeters equals 1 inch. Weight and mass. 1 pound equals 16 ounces. 1 ton equals 2,000 pounds. 1,000 milligrams equals 1 gram. 1,000 grams equals 1 kilogram. 1 kilogram equals 2.2 pounds on Earth. Capacity. 1 cup equals 8 fluid ounces. 1 pint equals 2 cups. 1 quart equals 2 pints equals 4 cups. 1 gallon equals 4 quarts equals 16 cups. 1,000 milliliters equals 1 liter. Fluid ounces are a capacity measurement for liquids. 1 fluid ounce is approximately 1 ounce weight for water only. Example 16. A bicycle is traveling at 15 miles per hour. How many feet will it cover in 20 seconds? To answer this question, we need to convert 20 seconds into feet. If we know the speed of the bicycle in feet per second, this question would be simpler. Since we don't, we will need to do additional unit conversions. We will need to know that 5,280 feet equals 1 mile. We might start by converting the 20 seconds into hours. 20 seconds multiplied by 1 minute divided by 60 seconds multiplied by 1 hour divided by 60 minutes equals 1 divided by 180 hour. Now we can multiply by the 15 miles per hour. 1 over 180 hour multiplied by 15 miles divided by 1 hour equals 1/12 mile. Now we can convert to feet. 1 divided by 12 mile multiplied by 5,280 feet divided by 1 mile equals 440 feet. We could have also done this entire calculation in one long set of products. 20 seconds multiplied by 1 minute divided by 60 seconds multiplied by 1 hour divided by 60 minutes, multiplied by 15 miles divided by 1 hour, multiplied by 5,280 feet divided by 1 mile, equals 440 feet. Try it now for a 1,000-foot spool of bare 12-gauge copper wire weighs 19.8 pounds. How much will 18 inches of the wire weigh in ounces? Notice that with the miles per gallon example, if we double the miles driven, we double the gas used. Likewise, with the map distance example, if the map distance doubles, the real-life distance doubles. This is a key feature of proportional relationships and one we must confirm before assuming two things are related proportionally. Example 17. Suppose you're tiling the floor of a 10-foot by 10-foot room and find that 100 tiles will be needed. How many tiles would be needed to tile the floor on a 20 feet by 20-foot room? In this case, while the width of the room has doubled, the area has quadrupled. Since the number of tiles needed corresponds with the area of the floor, not the width, 400 tiles will be needed. We could find this using a proportion based on the areas of the rooms. 100 tiles divided by 100 feet squared equals n tiles divided by 400 feet squared. Other quantities just don't scale proportionally at all. Example 18. Suppose a small company spends $1,000 on an advertising campaign and gains 100 new customers from it. How many new customers should they expect if they spend $10,000? While it is tempting to say that they will gain 1,000 new customers, it is likely that additional advertising will be less effective than the initial advertising. For example, if the company is a hot tub store, there are likely only a fixed number of people interested in buying a hot tub, So there might not even be 1,000 people in the town who would be potential customers. Sometimes when working with rates, proportions, and percents, the process can be made more challenging by the magnitude of the numbers involved. Sometimes large numbers are just difficult to comprehend. Example 19. Compare the 2010 U.S. military budget of $683.7 billion to other quantities. Here we have a very large number. Of course, imagining $1 billion is very difficult, so it can help to compare it to other quantities. If that amount of money was used to pay the salaries of the 1.4 million Walmart employees in the U.S., each would earn over $488,000. There are about 300 million people in the U.S. The military budget is about $2,200 per person. If you were to put $683.7 billion in $100 bills and count out one per second, it would take 216 years to finish counting it. Example 20. Compare the electricity consumption per capita in China to the rate in Japan. To address this question, we will first need data. From the CIA website, we can find the electricity consumption in 2011 for China was 4,693,000,000,000 kilowatt hours, or 4.693 trillion kilowatt hours, while the consumption for Japan was 859,700,000,000, or 859.7 billion kilowatt hours. To find the rate per capita per person, we will also need the population of the two countries. From the World Bank, we can find the population of China is 1,344,130,000, or 1.344 billion. And the population of Japan is 127,817,277, or 127.8 million. Computing the consumption per capita for each country. China, 4,693,000,000,000 kilowatt hours divided by 1,344,130,000 people is approximately 3,491.5 kilowatt hours per person. Japan, 859,700,000,000 kilowatt hours divided by 127,817,277 people is approximately 6,726 kilowatt hours per person. While China uses more than 5 times the electricity of Japan overall, because the population of Japan is so much smaller, it turns out Japan uses almost twice the electricity per person compared to China. Geometry. Geometric shapes, as well as area and volumes, can often be important in problem solving. Example 21. You are curious how tall a tree is, but don't have any way to climb it. Describe a method for determining the height. There are several approaches we could take. We'll use one based on triangles, which requires that it's a sunny day. Suppose the tree is casting a shadow, say 15 feet long. I could then have a friend help me measure my own shadow. Suppose I am 6 feet tall and cast a 1.5 foot shadow. Since the triangle formed by the tree and its shadow has the same angles as the triangle formed by me and my shadow, these triangles are called similar triangles, and their sides will scale proportionally. In other words, the ratio of height to width will be the same in both triangles. Using this, we can find the height of the tree, which we'll denote by h. 6 feet tall divided by 1.5 foot shadow equals h feet tall divided by 15-foot shadow. Multiplying both sides by 15, we get h equals 60. The tree is about 60 feet tall. It may be helpful to recall some formulas for areas and volumes of a few basic shapes. Areas. Rectangle. Area is length times width. Perimeter, 2L plus 2W. Circle, radius R. Area is pi r squared. Circumference equals 2 pi r. Volumes, rectangular box. Volume, length multiplied by width multiplied by height. Cylinder, volume, pi r squared multiplied by h. Example 22. If a 12-inch diameter pizza requires 10 ounces of dough, how much dough is needed for a 16-inch pizza? To answer this question, we need to consider how the weight of the dough will scale. The weight will be based on the volume of the dough. However, since both pizzas will be about the same thickness, the weight will scale with the area of the top of the pizza. We can find the area of each pizza using the formula for area of a circle. Area equals pi r squared. A 12-inch pizza has radius 6 inches, so the area will be pi 6 squared equals about 113 square inches. A 16-inch pizza has a radius 8 inches, so the area will be pi 8 squared equals about 201 square inches. Problem solving and estimating. Finally, we will bring together the mathematical tools we've reviewed and use them to approach more complex problems. In many problems, it is tempting to take the given information, plug it into whatever formulas you have handy, and hope that the result is what you were supposed to find. Chances are, this approach has served you well in other math classes. This approach does not work well with real-life problems. Instead, problem solving is best approached by first starting at the end, identifying exactly what you are looking for. From there, you then work backwards, asking, what information and procedures will I need to find this? Very few interesting questions can be answered in one mathematical step. Oftentimes, you would need to chain together a solution pathway, a series of steps that will allow you to answer the question. Problem-solving process. 1. Identify the question you're trying to answer. 2. Work backwards, identifying the information you will need and the relationships you will use to answer that question. 3. Continue working backwards, creating a solution pathway. 4. If you are missing necessary information, look it up or estimate it. If you have unnecessary information, ignore it. 5. Solve the problem following your solution pathway.